Assalamualaikum warahmatullahi wabarakatuh. Thank you very much for giving us the opportunity to present our paper at the second conference of Innovation, Technology and Engineering Sciences. Before we begin, I would like to introduce myself to all of you. My name is Taufika Ophiyandri. I am from Civil Engineering Department, Andalas University. This paper was entitled "The Study of Retention Pond and Infiltration Wells to Reduce Flood Risk Due to Resettlement at the Batang Kuranji Upper Watershed." This paper was also written by my colleagues, Bapak Bambang Istijono, Bapak Andre Gromiko, Bapak Beni Hidayat, Bapak Junaidi, and Bapak Nur Rajamil. I divided this presentation into four sections. First is the introduction, where I will explain the background and objective of the paper, followed by its methodology. After that, we will discuss the result that we obtained from the research, and finally the background of this paper is because in recent years, Batang Kuranji watershed has experienced significant development, especially after earthquake on the 30th of September 2009. Since then, due to tsunami risk, large number of community near the coastal area, which is the downstream area of the Batang Kuranji watershed, begins to move to the upstream area. As a result, there has been significant changing in land cover at the upstream area. As you can see from the left photo, in 2005, the area was mostly rice fields. Buildings were still very rare. But in 2019, due to development for infrastructure such as office buildings, roads, houses, schools, the green area for water infiltration has reduced significantly. This condition exacerbated by the climate change. Thus, the peak discharge of Batang Kuranji might increase. However, the Batang Kuranji channel, with a design capacity of 870 cubic meter per second, might not be able to accommodate the changes. So the objective of this paper is to calculate the existing Batang Kuranji discharge and to propose structural mitigation effort to reduce flood risk. The methodology we use for this research is: first, we calculate the rainfall distribution using the Gaussian polygon. From the table on the right, you can see the percentage area of each rainfall station. We conducted the analysis on the rainfall data in 20 years from year 1999 to 2018. Then we analyze on the probability for the rain return period to 5, 10, 25, 50, and 100 years to determine the flood Q using two methods: the Nakayasu HSS method and HACK HMS application modeling. So, as the result of the study, we found that normal distribution was the best fit to be adopted as a rainfall forecast. Then, we conducted two methods, Nakayasu method and HACK HMS method, to calculate the discharge of Batang Kuranji. We found that the peak discharge using Nakayasu method was 919 cubic meter per second and 1037 cubic meter per second for HEC HMS, while the design for Batang Kuranji Channel was only 870 cubic meter per second. So, if we compare the design and run off this chart, as can be seen from the picture on the right, the design for the discharge at the subwater set is 600 for Batang Kuranji and only 270 for Batang Belimbing. Then, we found that the existing peak discharge at the Batang Belimbing was higher than it was designed. From the table below, we can see that Batang Belimbing subwatershed is experiencing an overcapacity of discharge at 292.9 cubic meter per second. So, flood risk measurement has to be taken place. In order to reduce flood risk, we propose two methods for structural mitigation effort. First, with so-called infiltration wells. So by assuming one house uses one infiltration well with the absorbed and floating volume total 5 meter, 5 cubic meter, the manageable runoff volume is 171,000 cubic meter. As seen from the retention pool runoff volume, it is able to reduce by 9.02% from 1.8 million cubic meter per second. Secondly is by creating retention ponds. The remaining discharge after deducting from infiltration wells is about 1.7 cubic meter. There are actually several potential places where we can build retention ponds. One is the area next to the major office. The area is 35 hectares, so by digging 5 meter, we can create about 1.70 million cubic meter retention pond. We can conclude that first, the Batang Kuranji channel can no longer accommodate the peak discharge which occur at the third hour of 1000 cubic meter per second. The discharge at the Belimbing subwatershed increased by 292.9 cubic meter per second. Increase in discharge occurs at 3 to 5 hours with a volume of nearly 1.9 million cubic meter per second. And finally, infiltration wells and retention ponds are proposed as structural mitigation strategies for flood risk reduction. Thank you and Assalamualaikum warahmatullahi wabarakatuh.